Okay, hello everybody. So in today's lesson, we'll be continuing with probability, ELR 13.4. It's dealing with the topic called compound probability. But before we start, I'd like you to do the warm-up like if we were in class. Go ahead and complete 1 and 2 here. Pause the video, and then we'll talk about the answer on the next slide. So for the first example, we have Mark has 5 pants and 7 shirts in his closet. He wants to wear a different outfit each day without buying new clothes for as long as he can. How many weeks can he do this for? So first we need to figure out all the combinations of outfits that he can have with 5 pants and 7 shirts, and that's the counting principle. So we know that we're going to be multiplying here. So 5 times 7 is going to give us 35 outfits. How do we get 5 weeks? Well, there's 7 days in a week. 35 divided by 7 gives us 5 weeks. For number 2 there, we have a license plate. And the pattern is that they all have the same pattern of 3 letters followed by 3 numbers. Repetition is allowed. So for that one there, I would have my 3 letters followed by my 3 numbers. Repetition is allowed, so that means 26 letters in the alphabet. So for each position for the 3 spots, there are 26 possibilities. The digits 0 to 9, there are 10 of them, and again, it can repeat. And when you put that in the calculator, you get this big number, 17,576,000. Okay, so today's objective is that students will be able to identify independent versus dependent events. What are the difference between those things? And then they will be able to find compound probabilities dealing with what we're talking about in the sentence. So let's talk about independent versus dependent probability. If we were in class, I would have you talk with your group. What is the difference between an independent and a dependent event? And can you think of an example for each of them? So independent events are events that don't rely on each other. They're totally different things. Dependent events are events that do affect each other. So I don't know if you were able to think of an example of each, but one would be for an independent event, maybe rolling a die and then tossing a coin. These two things are completely different from each other. One does not affect the other. A dependent event, an example could be you take a card out of a deck of cards and you don't replace that card, and then you take out another card. So because we're talking about taking a card from a deck and we don't replace the first time we take it out, it does affect the other event that's happening. So in these next couple of slides, you're going to identify if you feel this event is independent or dependent. Okay, here is the first one. Is this an independent or a dependent event? You choose a number tile from 12 tiles, then spin a spinner. Definitely independent. These two things are different from each other. Next one. You pick one card from a set of 15. Then, without replacing the card, you pick another one. This is definitely dependent. Just because it says you didn't replace the card, that will affect the next event, so it depended on it. You roll a standard number cube, which is a die, then you flip a coin. Totally different things. That's an independent event. You have 3 red Skittles, 2 green, and 4 purple Skittles in your pocket. What is the probability of drawing a red Skittle, eating it, and then drawing a green Skittle? Well, because you ate the Skittle, it will affect the amount that's left in the pocket, so these are dependent events. Okay, today we're going to be getting 3 different formulas. So, if you have events that are independent, and I am specifying them as event A and event B, depending on what they're about, this is the formula we're going to be following. Another important thing to realize is that there is a word in here called AND. So we're going to be looking for AND also in the problem. So the probability of these 2 events, A and B, what do we do to get the answer is we find the probability of both of them and we multiply them together. So write down that formula for sure. Let's take a look at this first example. What is the probability of flipping a coin and getting tails and rolling a die and getting a 1? So first you have to understand that these are independent events, coin and a die. It also has the word and in here, and that's important also. So event A is going to be flipping the coin. Event B is going to be rolling the die. So if I follow the formula, probability of A times the probability of B. So what's the probability of getting a tail? Well, that's a half. Timesing it by the probability of getting the number 1 on a die. Well, there's only one 1 on a die. That's 1 out of 6. And now we're going to multiply 1/2 times 1/6, which is 1/12. All right, let's take a look at 1 and 2. If you feel that you want to do this and pause the video and try it yourself, go ahead. I'm just going to go ahead and start doing the problems. A day of the week is chosen, and a month is chosen at random. What is the probability of choosing Sunday and a month that begins with an M? So one more time again, are these independent? Yes, they are. You're choosing a day of the week versus a month. It also has the word and in there too. Okay, so let's go ahead and figure out what's event A. Event A is probability of choosing Sunday. And event B, timesing it by the other event B, is probability of choosing a month that begins with M. Okay, so to pick Sunday would be 1 day out of the 7 days of the week, 1/7. To pick a month that begins with M, there are only 2 months that start with M, March and May. And there are 2 out of a total of 12. So if I multiply this, I get 2 out of 84, which reduces to 1 out of 42. And you could also go ahead and put it as a percent if you'd like. All right, number 2, we have a box containing different colored pencils. A colored pencil is chosen at random. It is not replaced, then another is chosen. What is the probability of choosing a blue, then yellow colored marble? Okay, so for this one here, let's think of the 2 events. Now, this is not an independent event because we are not replacing the pencil once we take out the first one, but we are still going to be following the same formula, still multiplying the 2 answers together. So I want to first find the probability of choosing a blue, and I'm going to times this by the probability of choosing a yellow. So the probability of choosing a blue pencil. So to choose a blue, there are 7 pencils, letter blue, out of a total of 21, 7 out of 21, and that reduces to 1/3. Now, think about it. When I go back in the box, there is only 20 pencils left. So the probability of then choosing a yellow would be 6 out of 20. And 6/20 reduces to 3/10. Now I'm going to multiply across, 3 on the top, 30 on the bottom, which reduces to 1/10. Okay, so just be careful. You're still using the same formula for both multiplying, even if it's independent versus dependent. All right, now we're going to be moving on to another different type of compound event, which is called a mutually exclusive events or disjoint events. I've seen both names. And these are 2 events that cannot happen at the same time. So, pause the video. Can you think of an example that's describing this? I mean, one example could be, you toss a coin, what's the probability of it either having a heads and tails? And that's impossible, right? Because you can have only head or a tail. Another possibility is if you're have a deck of cards. What's the probability of drawing a king and a queen? Just because of the word and, that's impossible. There is no such card that has a king and queen on it there. So be careful of the wording. So let's write down what it says here. If A and B are mutually exclusive events, then if you have the word and in the problem, that answer is impossible. Like I was just telling you those examples, that's 0. If you have the word or in there, now here's totally different than the other one. You're going to be adding the two probability of these events together. All right, so let's look at 2 examples. This is on deck of cards. So if you're not knowing what are in deck of cards, make sure you definitely review that for yourself. So the first one says, what is the probability you draw a spade? Or, so there's the word or, a diamond from a deck of cards. So because it has the word or, I'm going to be following this formula up here. I'm going to find the probability of both events and then add them together. So the probability to get a spade, there are how many spades in a deck? 13 out of a total of 52. Plus the probability of a diamond. Again, there are 13 diamonds. 13 out of 52. So when I add them up, I get 26. The denominators are the same out of 52, which is exactly half of the deck. All right, let's talk about the second one here. What is the probability you draw a spade and a diamond from a deck of cards? So, because it has the word and these two events have nothing, is impossible to take a card out of a deck that's a spade and also a diamond. So the answer for number 2 is 0. Okay, last type of compound event is called an overlapping event. An overlapping event is where sorry about that, erase that. A compound overlapping event is 2 events that share something in common. So the formula is going to be the same as the other one from the previous slide with that word or there, right? We're finding the probability of both events and adding them, but we're subtracting what's common between the 2 events, what's common. So we're going to have a couple examples for this one. What is the chance of rolling a die and getting a multiple of 3 or multiple of 2? So on a die, we have 1, 2, 3, 4, 5, 6. These are definitely overlapping, so we're going to figure out the probability to get a multiple of 3 first. And what are multiples of 3? 3 for sure, and 6. So that's 2 6ths plus probability of getting a multiple of 2. Well, how many multiples of 2's are there? 2, 4, and 6. So that's plus 3 6ths minus what's common? What is a multiple of 3 and also a multiple of 2? So take a look at what I have over there on the left side. Both 6 is a multiple of 3 and also a multiple of 2. So that's one possibility out of the 6 on the die. So if I add and subtract my numerators, I have 5 minus the 1, which is 4 6, which reduces to 2/3. Okay, on pretty much our last slide, I believe. Yes. So you could pause the video and try these first, and then listen to me, and we'll go through it together. Okay, so what is the probability of rolling an even number or a multiple of 3 on a die? So I already have set up here each event, probability of even, plus probability of a multiple of 3, minus what they share in common. So to get an even number on a die, That's doing 2, 4, and 6, so that's 3 6 or a half. Multiple of 3, that's 3 and 6. So that's 2 possibilities out of the 6. Minus, well, where is the commonality? It's right here. 6 is a multiple of 3 and also even. So that's minusing 1 out of 6. So we don't repeat that value. So I add and subtract. 3 plus 2 minus 1 is 4 6 or 2/3. All right, for number 2 here, what is the probability of rolling a 3 and, so here we go, and a 6 on a die? Is this possible? It is not. If I change this to what's the probability of rolling a 3 or a 6 on a die, then we could definitely get the probability of both events and add them together. But because of the N word, we can't evaluate it. So be very careful looking at the questions, and versus or. All right, last one, number 3. Okay, so what is the probability of rolling an odd number or, so we have the word or, a number less than 4? So I already have it set up here. I separated the two events, probability of odd plus a number less than 4 minus what's the commonality of both of them together. So let's do probability of odd, 1, 3, and 5, that's 3 6, plus probability of a number less than 4. We have all 3 numbers here that are less than 4. So again, that's half of the dice, 3 6, minus, well, what's odd and also less than 4? We'll take a look. This one and this one. 2 possibilities out of the 6. So I'm going to add 3 and 3 minus the 2. I'm getting 4 out of 6 or 2/3. Again, just like the first problem. All right, so hopefully you have these things in your notes. So take a look. Be careful. This top one and this bottom one are pretty much the same. You just have to understand if these events are mutually exclusive or are they independent-dependent events to do the first one there. So for the top one here, you're using independent events for this. Also dependent events. Mutually exclusive are things that are impossible to do because it's not possible to have those answers in your question. So the answer is always 0. And then the or problem is important. Usually that's for overlapping events. There. So what you're going to be doing now is Math Excel 13.4. Please use the help button, help me solve this button as you're working through the problems. And then on class, when I see you next class, we're going to be continuing. We're going to just do a little review on 13.4, but we're going to get into our next big section, 13.5.